Geotrig, this is lesson 10, day 2. So we're going to talk about rational denominators. Basically, rational denominators, well, first of all, a rational number is just a repeating decimal, anything that can be written as a ratio or a fraction, and a terminating decimal. Those are all rational numbers. And when I say a rational denominator, means I have one of these things happens to be just in the idea of a denominator. Examples of rational numbers, just to throw some out there, 5 is a rational number. 2.75 is a rational number. 0.3, repeat, is a rational number. What else do we have?
4.
4 would definitely be. I'm trying to make sure we got everything that's here. 3/4. Basically, anything that can be written as a fraction is a rational number. We generally don't like any of these things actually in denominators, except for the first one, which would be 5, which we consider an integer or whole number. Those types of things. Irrational numbers are non-repeating decimals, basically kind of the opposite. Can't be written as a fraction, aka non-terminating. So if it's not repeating and doesn't stop, therefore it's irrational. Some of the easiest and most well-known ones, pi. One you've used probably or seen, square root of 2. Square root of 2 is 1.414 and on and on and on. Square root of 3, those things, e. I think last year you guys should have been introduced possibly to E. 2.713 or 718, I think it is. So those are all things, guys. Non-repeating decimals, non-terminating. So kind of the opposite of what some of those ones above are. You can't write it as a fraction. Just can't. And then complex number are numbers that involve what particular letter? I. I, guys, is what we're going to consider to be something we don't like in denominators as well. Now, I have below, there's a couple things that we need to remember. You need to remember that square root of 5 times the square root of 5 is equal to the square root of 25, which is just 5. A square root times itself basically will cancel out the square roots. It's just a number. You're setting up partners to go to the dance, guys. The next two are very much interrelated here. We have the square root of a negative number. And we don't like square roots of negative numbers. I think we had a lesson on this. And the square root of negative 1 is I. And if I square both sides, I squared is equal to negative 1. That's why we partnered up all of our i's. Remember that? That was in the last quiz. All of these things are things we don't like in the denominators. So if you were to see 1 over the square root of 2, we're going to fix it. 1 over I, or actually i's in general, we just don't like on the denominators. It can be anywhere. And remember, this could be even 1 over 3 plus the square root of 2. It's got its own steps, really close, to get rid of both of these. So, I sat down and created a process or a bunch of steps. And there they are. The process of converting the denominator to a rational number is called rationalizing the denominator. Step number 1, to rationalize the denominator, you must multiply both the numerator and the denominator by the conjugate of the denominator. Whoa. We'll get to there in a second. Remember, to find the conjugate, all you have to do is change the sign between the terms. So like the problem we did before, where it had 3 plus the square root of 2, is it 3? Oh, we'll go back. It was 3 plus here. 3. Wrong color. Put my cursor on there. Why do I keep doing that? Here we go. It's 3 plus the square root of 2. Its conjugate would be the opposite sign in the middle. So it would be 3 minus the square root of 2. Okay, let's go back. And all you do is multiply that to the top and bottom. If you look at the problem below, it's 5 over the square root of 2. There is no plus or minus going on. It's a single term. So it's going to be slightly different, a little bit easier than actually these steps here, but you can follow them the same exact way. To distribute or FOIL both the numerator and the denominator separately, remember that you can multiply numbers outside the radical with numbers outside the radical and numbers inside the radical with numbers inside. If it's a square root times a square root, you take the numbers inside the square root and multiply them. If there's anything attached on the outsides, they can be multiplied together. That's commutative property, right?
Yeah.
Or is it the associative property? Associative, I think, is when you have more than just 2 or 3 at a time. Then, combine any like terms, simplify any radicals that are left because you multiply numbers inside, combine like terms again, and then reduce the fraction if you can. Again, the whole idea is that I do not like that thing of a square root in the bottom. So, I'm going to show you one that has simple steps like this one, and one that will actually follow these steps a little bit closer. Notice that there is nothing in front of the square root of 2. There is no plus or minus. So actually, I'm going to not necessarily skip number 1. It's going to be a modified step. I don't need to multiply by the opposite sign. I just need to multiply by something that when multiplied to the square root of 2 cancels the square root. Square root of 2 times what will make it go away? Square root of 2. So I'm going to change colors so we can see that. I'm going to multiply the bottom by square root of 2. But whatever I do to the bottom, I have to do to the top. And so yes, the top, I cannot put these together. Be very mindful of that. One's inside a square root, one's not inside a square root. They don't go together. So it's 5 times the square root of 2. Over 5 square root of 2, times square root of 2. It's 2. And then you just ask yourself, can I simplify that? Is 5 divisible by 2 nicely? No. It wouldn't leave it as 2.5 square root of 2. So guess what? That's your answer. I can't simplify the square root because square root of 2 is broken down to its prime factorizations. It's already done. No partners. So therefore, I'm done. Any questions, guys? Okay, so now we're moving up in this idea that we need to rationalize because I don't like square root of 3. I don't like it. I don't like the square root of 3, not because it's on top. I don't like it because it's on the bottom. Now, guys, here's a really cool thing as well. We all have calculators that can do this math. I can put 2 minus the square root of 3, enter, divided by square root of 3, enter. I'll get a decimal. If you were to do this after we mess with it to change it, to rationalize it, you should still be able to get the same decimal with your little new equation or expression and the original. They are the same. So if anything, you will know if you did something wrong. Check it. Now, again, on this particular problem, there is no plus or minus. So I'm just going to multiply the top and bottom by square root of 3. Square root of 3, square root of 3. But the top, guys, has a binomial on it, which means you need to distribute it. Square root of 3 times square root of 3 is just 3. That's the nice part. We engineered it to turn into something nice. Now, you have to ask yourself, square root of 3 times 2? No. It's 2 3 minus a negative, okay, a negative square root of 3 times a positive square root of 3. It's a negative 3. The question now you need to ask yourself is, can I put together 2 square root of 3 minus 3? Can I simplify everything by dividing it by 3? So guess what? That's it. Now wait. The next problem. Guys, the next problem says it's 6 over I. What's the big deal? Why don't we like I? More than that. It's the square root of negative 1. It's a square root. It just represents a square root, which we still don't like in the bottom. So yes, I heard someone say it. We multiply top and bottom by I. So the top becomes 6I over I squared, which is negative 1. I can simplify that to be what? Negative 6I. Hoping that you guys are not finding this to be too bad. Next. Okay, guys. Now we just kicked it up to about one of the hardest problems that you would probably have to deal with. Now, could there be multiple pieces in here instead of just a binomial over a binomial? Yes. It might take a lot more work to get it done, but this is pretty much the piece that's going to give the most traction. Yes. This, guys, is where you have to multiply by the conjugate, which means the opposite. Notice that we still have a square root on top, but we also have it on the bottom. The bottom's the culprit. I don't like it. What do I have to multiply the top and bottom by?
3 minus the root of 2.
3 minus the square root of 2, correct. And what I do to the bottom? Guys, this is where I think it's very important that you put parentheses around everything. Because that way you recognize you have a binomial times a binomial, aka you have to use the 4-letter F word, FOIL. So, the cool thing about the denominators when foiling is the sum and the difference. Does anybody know what happens when you multiply or FOIL the sum and difference of numbers? You end up with a certain formula that you guys all should know. A squared minus B squared. The difference of squares. You will end up with a nice number on the bottom. But if we're not there, we're going to go old school, FOIL. 5 times 3. 15. 5 times negative square root of 2. Negative 5 square root of 2. Negative square root of 2 times 3, which is a minus 3 square root of 2. And what is a negative square root of 2 times negative square root of 2? Positive square root of 2 squared, or 2. Working on to the denominator. 3 times 3? 9. 3 times a negative square root of 2? Negative 3 square root of 2. Square root of 2 times 3. It's a positive square root of 3 over times square root of 2. And a square root of 2 times a negative square root of 2 is minus 2. What happens to the middles in the bottom? They cancel. What happens to the middles on top? No, they don't cancel. They're like terms, though. I did that on purpose, guys. I was hoping some people would say that. So, the denominators, they cancel the square roots out. There are no more square roots. That's what we're aiming for. And what's 9 minus 2? So 7. On top, remember, you should always put your constants first, and then anything that's kind of not so nice after. Just good etiquette. 15 plus 2. And then minus how many square root to 2's?
8.
Oh, wait.
And then boom. Can I reduce any of that?
No.
No. The only way I could cancel out that 7 on the bottom, guys, is if I could factor out a 7 out of 17 and 8, and I don't think I can. Okay, guys, remember the last problem here of 1 over 2 plus I again is like a square root. So I need to multiply the top and the bottom by 2 minus I. And what I do to the bottom, I do to the top. Now, the nice thing about this particular problem is that the 1, or the top of the original fraction is a 1. And 1 times anything is the same thing. It doesn't change it. So we like that. Is everybody okay with that? It just becomes 2 minus I on top. The denominator, though, you have to FOIL. Now, eventually, you should get to the point where you recognize that you know you just created the difference of squares. At that point, go ahead and use it. But we're not all there. So, 2 times 2? 2 times negative I?
Negative 2I.
Negative 2I. And then I times 2. Positive 2I. And then I times negative I. And I would definitely, when working with i's, write it as negative I. So on this particular problem, before I can rationalize it, I think I want to simplify it. If you guys can think of this, I to any power bigger than, what is it, 0, 1, 2, 3 or above, guys, can be simplified, even I squared. There's only like 3 choices. You have I, negative I, or positive I. So I to any power will become one of those 3 choices. So if you have something that has an I with a power on it, simplify it first, then you can continue on. So to simplify it, expand it, right? 2 minus I plus 2 I all over. That wouldn't change. But this will change. Why would I change this? You cannot, we're going to circle up, parting them up, but can't cancel with things on the bottom. Because it's not in everything. But, guys, the bottom does need to be changed. It doesn't change its value, but it's going to change the way it looks. You need to put it into standard form. Because if you don't, this problem will not work if you leave it as negative 2I minus 4. It has to be a positive 2I plus 4. And so you may want to change this to put it in standard form. So we start circling up our partners. I. So 2 minus I times negative 1 plus 2 times negative 1 I all over 4 minus 2I. I? Negative negative makes a positive. Negative negative makes another positive. And so, cleaning this up again, 2 plus I plus 2I all over 4 minus 2I. Oh, wait, we can clean that up yet again. Two plus I plus 2I make 3I. No, we are not allowed to cancel the i's from the top and bottom because I is not in everything. I can actually take a 2 out of the 4 and the 2i from on the bottom, but I can't take a 2 out of the 3. So therefore I can't cancel a 2 either. Now we revert back to what we did in the last problem and multiply the top and bottom by what? 4 plus 2i over 4 plus 2i. And you need to FOIL the top and the bottom before you simplify. I'll let you guys finish that problem. Homework is page 81, 7 through 11, and 23. Have a great day.